Intro Algebra Lesson 4-1b. Last time we were discussing for the first time the coordinate plane and the system involving the coordinate plane and ordered pairs, the x and y axes, and the fact that all ordered pairs are made up of an x value followed by a y value that combined gives a very specific location on the coordinate plane. Today we want to look at some different types of graphs you might see, one in particular known as a scatter plot. So the name scatter plot, the plot portion of scatter plot, when we plot points, we're putting those points on the coordinate plane. It's the act of graphing. So taking ordered pairs or data and putting them in their specific location onto a coordinate plane system. Scatter simply means that some of these plots might not be in a perfect line. They may be kind of in disarray or looked, in other words, scattered. So a scatter plot is simply taking data and putting it onto a coordinate plane. From that scatter plot we can analyze, we can look at the relationships of the data and decide whether there's any connections, the relationships between the x and y values. Now the x and y values might be other terms. They might be gas mileage, they might be ages, they might be height, they might be time. There's a lot of things those values could be in the real world for these scatter plots. Some relationships that you might think about. For one, as time continues and you have a newborn child, as time progresses, that child is most likely going to grow. So as time goes up, the child's size goes up. Now that won't happen forever, but at some point there is usually a positive relationship between the size of the child and the time that's taking place. Another example might be the more you drive your car, the amount of gas in the tank goes down. So that's a negative relationship because as time goes up, one is going down, the gas amount in the car is going down. And sometimes there doesn't seem to be any relationship or connection at all. For example, the month that you were born has no connection whatsoever to what color your eyes will be. So that would have no connection. So we can look at our graphs and we can decide whether or not there seems to be a relationship there. So here's one particular scatter plot, and you can see the dots they're put on the coordinate plane system. They do seem scattered, but as you look at it, the way we want to read graphs is just like reading a book. From the left side of the graph to the right side of the graph, it appears as if the dots are going up. We always read from left to right. So it looks like the dots are going up. Sort of seems like they're going like that. I know it's not a perfect straight line, but that just seems like the trend would continue. So this would actually fit the pattern of what I mentioned before about the ages. As a child gets older, they tend to get taller or bigger. So it's not that that will happen forever, but there is that sort of relationship. So we would call this a positive relationship. There seems to be a positive correlation, connection, relationship between those values. All right, looking at another example, now you look at the graph from the left side to the right side, and it appears as if the points are going down. So this is not the same. This is a negative relationship. In our first example, as x got bigger, y got bigger. As x got smaller, y got smaller. Now, as x gets bigger, y is getting smaller. As x gets smaller, y is getting bigger. That would be an example like the gas that I mentioned. As we drive further, we have less gas in the tank. So there's a negative relationship for that. So that's an example of a positive relationship, and this is an example of a negative relationship. Reading from left to right the graphs. Now, in this next one, you'll notice that once again, it looks as if from left to right, that the graph, the points, are going up. And so again, this is a positive relationship. But now that we have two different graphs that both have a positive relationship, we're going to add more words to try to describe them. This graph, the scattering isn't quite as bad as it is up here. They're starting to get closer and closer to becoming a line, which means that the relationship between x and y is getting stronger. So this would be considered a strong, positive relationship. This is still a positive relationship, it's just not as strong, so we would call it a weak, positive relationship. And if we have strong and weak positive relationships, that probably means we're going to have the same for negative. And so looking at this one here now and comparing it to this one, We again see that this is a negative relationship because it's going down, but it seems a lot stronger than this one. So we would say this is a strong negative relationship. And if that's a strong negative relationship because they're tighter and closer to becoming aligned, then this would be a weak negative relationship. So there you have 4 different scatter plots. Weak positive, they're going up but more scattered. Weak negative, they're going down but more scattered. Strong positive, a little tighter going up, and strong negative, tighter going down. There is one more. I did mention the color of your eyes and the month that you were born. And here's an example of a scatter plot that doesn't seem to be going up or down. This would be an example that we would call no relationship, or no connection. No relationship would be good. You can't tell from that graph, reading it from left to right, if the points are actually going up or down. There's not enough conclusive data there to help us determine that. So we can tell a lot from a scatter plot how values are connected. And if they're real life values, like I mentioned before, time, gas, ages, it could be a gamut of things, then we can tell whether or not there's a connection between those values.